This is Group 16. This is our mini project. The goal of our project is to create a COVID-19 pandemic mask that regulates the temperature inside the mask to stop fogging of glasses and make the user more comfortable. The requirements for our project is to have a temperature sensor read the temperature inside the mask, communicate it to a microcontroller. Then the microcontroller will communicate the sensor's input in Fahrenheit to a Bluetooth module, also to activate the fan to regulate the temperature. The phone will read the Bluetooth temperature and let the user decide whether to turn the fan on or turn it off. And then the next is our circuit diagram for our design with the bill of materials. And the
Here I
sample.
have a use case of an example for the mini project. I go more into that in demonstration in the next slide. Hi, my name is Brandon Witt, and I'm from Group 16, and I'm here to do a demo of the mini project we were working on. So what we decided to work on was the temperature controlled fan, and let's just jump right into it. So what will the user be able to do? Well, the user shall be able to turn the sensor off. The user shall be able to change the strength mode of the fan, and the fan shall turn on or off automatically in the appropriate temperatures. So 1 and 2 are basically saying that regardless uh, of the temperature when the fan is on, the user should be able to turn it off. And also while the fan is on, you should be able to change the strength of the fan, which we will control using 2 switches implemented into the breadboard. If we go to the last picture actually on the first page, you'll notice the 2 lights on the left, the 2 red lights, for pin 6 and pin 1 on the switch. Those will basically control the state of the fan. We'll get more into that when we go into the demonstration. So how will the process look? Right now we have a sequence diagram. The user will breathe into the temperature sensor. It'll sense the temperature and then make a comparison. If it is above the threshold that we provide, then it will check if the state is changed. If the state has changed, then the output will change. If it is below the threshold, then it will not call any out function. When we call the out function, it'll check the current state of the switches. At 0, 1, the fan will be weak. At 1, 1, the fan will be strong. And at 0, 0, the fan will have no response. So if we look at basic skeleton code for this, we'll get the temperature, we'll store the previous state, we'll check the current state. If the states have changed, then we'll change the output, and we'll print that data to the screen every 1000 cycles. So before the demonstration, I want to get into what we're actually printing to screen. This part on the left is just the time of print. It's built into the Arduino, and I was using it during testing just to show the sequence of printing. These next 3 bits are basically the current state of the fan. From left to right, on the far left we have the on-off bit. This bit basically tells us whether the fan is running or not. As it is 0 right here, it is telling us that the fan is not running. These next 2 are the switch bits, and they will tell us whether switch 1 and switch 2 are on or off. This next number is the current temperature, and we are using Fahrenheit. And this final number is the stop variable, which will keep track of how long we are below the threshold. If this number reaches 2000, the fan will force off because we are below the threshold for too long. So let me get my camera to show the temperature sensor. And then we'll bring out the Arduino. And we'll show the output later. So right here we have the temperature sensor. And then these 3 lights are the bits for the state. So this light right here is the switch 1. This light right here is switch 2. And then this light right here is the on-off bit. Basically, if the blue light is on, then the fan should be running. If the blue light is off, then that means the fan is also off. If we go into our output, we shouldn't see anything because it's not sensing right now, but it'll start once we turn one of the switches on. So turning switch 1 on, we notice that the output starts and switch 1 is on, but those 2 bits on the left are 0 because switch 2 is off and the fan is still off. If I turn on switch 2, we get our states become 0, 1, 1, but the fan is still off. So we'll go to the temperature sensor. I'll put my hand over it, use my body heat, and the fan starts turning. The blue light is on and the fan is on, and our current state in the output is 1, 1, 1 because the fan is on, switch 2 is on, switch 1 is on. And then of course we can mess with the fan modes. Let me keep the temperature up. We can mess with the fan mode. So if I turn one switch off, then the fan will slow down and become a lot weaker because we are in a weaker fan mode. And then if I turn the second switch off, the fan will stop altogether. The blue light turns off. Oh, sorry. The fan will stop altogether. The blue light turns off, and we are no longer printing output to screen. So I'll turn switch 2 back on. I'll go above the threshold. The fan turns on. It's in a weak mode right now. I'll turn the second switch on. It's a lot stronger. And then at any point, if we want the fan to stop, then we'll turn both switches off. Of course, the fan is also supposed to automatically turn off if the temperature gets too cold. So if you look at the stop variable in our output, you'll know if I keep my hand off that temperature sensor, then eventually the temperature will go low enough to turn off this fan even when both switches are on. As you see, we were below the threshold, and now the fan has stopped. Thank you for watching. This was the demonstration of our temperature-controlled fan from Group 16. So Louise, your turn now.
Okay. So I designed the component, the app, which receives the data from the Arduino from the Bluetooth. So the Arduino provides the data to the Bluetooth, and I obtain the data from the Bluetooth to the app. If you can go on to the next slide, this is kind of like how the code worked, and this is the case the users will go through, but it can be better explained through the short demonstration. So I just deployed the app. Before you can use it, you do need to sign in. It uses Firebase to sign in, so any of these methods will work. I am going to use Google because it is already saved to my device. So then the next step is that you need to select the Bluetooth to pair with the app. So this button will display all the devices currently paired with your mobile device. So if you have not yet paired the Bluetooth with your cell phone, it will not work and it won't show here. So they have to have been previously paired. So this is my Bluetooth device. I would select it. All right, so right now the fan, as we can see, this is the current temperature and the fan is off. I did have to change the threshold for the purpose of this video to a much higher threshold to be able to demonstrate the fan being on or off. And I'm going to go ahead and heat up the sensor so we can see when the fan is on. So we see when it got above 80 degrees, the fan turned on and the temperature is still being currently displayed. So when when the user no longer wants to use the app, they can just disconnect and they can sign out.
All right, Eric.
Hi guys. All right, so this is the high-level architecture we have. So currently, what we have is the temperature sensor will go through the Arduino, which is connected with the fan and a Bluetooth transmitter, where it will transmit the data to a mobile app. If we can implement a database, we would use AWS IoT, and I'll explain further on the next slide. So for the database implementation, how could we improve our data transfer? Well, currently we are using a Bluetooth connection. What we can do in the future is implement where we have a Wi-Fi transmitter, and that will make it more productive and easier to relay our data to a database with AWS. And on the next slide, we're going to see how that looks. So data logging with AWS, we would use IoT, which stands for Internet of Things. It allows us to connect to the internet for processing, operating, and exchanging data securely. What you would need to do is set up your account and download a few certificates, which you will put into a code. These certificates would be a certificate for the thing, a public key, a private key, and a root for it. And then depending on the hardware and the microcontroller you use, you would upload these certificates into a certain file system. And then you would execute your code. And then on the next slide, we're going to see how that will work. So the brief rundown is the Wi-Fi and the IP address will connect and read the certificates that you created. The MAC ID will be read and printed and initiate MQTT connection. And this will connect to the AWS cloud. We'll publish a JSON data to the MQTT, and then while the temperature is being displayed on the application Louisa made, that will relay the temperature into AWS and be stored into a database. And then on this slide are resources that we think that will help, and that will conclude our project for Group 16.